Hey guys, welcome back to another RASK maths tutorial, and in this tutorial I'm going to be showing you guys how we can actually bypass the harmonic form for equations of the form a sine x plus b cos x equals c. So generally the way most people are taught how to solve these kind of equations is to put this left side into harmonic form and then solve it just like a regular sort of compound sine or cos equation. And that can work in other ways, to square both sides and then divide it by either cos, I think it's cos, just to get a quadratic in tan, and that's also a way. And yeah, so in this video I'm going to be showing you guys how we can actually bypass that. But in order to do that, first let's show you guys how the harmonic form actually works. So let me pick an example. I'm going to do something like, let's have 1/2 sine x plus root 3 over 2 cos x. And let's just set it equal to, I think we'll just put it as 1/3. Doesn't actually matter. Actually, no, let me pick a number which is nice. I'm going to pick root 2 over 2. Now, you might know why I've picked these numbers, just because they mean I can do calculations without having to use a calculator. But yeah, the way a harmonic form method works is we essentially rewrite this left side in the form of a compound angle. So in our case, since it's sine and cos as separate terms, we would probably use the sine addition compound angle formula using alpha as our extra variable, but it doesn't actually matter. We could also use cos. The thing you need to be careful of is that you have different signs, so that's why I always tend to use sine, because it's just easier. And then if we expand out this right hand side, you'll see this gives us sine x cos alpha plus cos x sine alpha, like so. And then we can do something like this, and we actually have to add an r, a constant in front, just so we can go outside of a range of just 1 to 0 to 1, or in the case if we add sine and cos, I think we can also get up to root 2. But yeah, we add this r, so if we expand this out and distribute the r, this is what we'd get on the right side, and then let's just keep the left side exactly the same. Now notice how this is a identity, so it's going to be true for all values of x, which means we can just equate coefficients, because the left side has to be equal to the right side, which means this 1/2 is equivalent to the r multiplied by cos alpha, and this root 3 over 2 is equivalent to r multiplied by sine of alpha, with these cos x staying the same between them. So this is going to give us a system of equations where r cos alpha equals 1/2 and r sine alpha is equal to root 3 over 2. So let's add that in now. And now we just have to solve this system of equations for two unknowns. Pretty simple. So first thing I can do is just eliminate that r by putting equation 2 over equation 1. And this is actually going to give us tan alpha using an identity. The tan equals sine of the cos identity, and if we put the constants in, that's going to give us root 3 over 2 multiplied by 2, and that's equal to root 3. So from this we can figure out that alpha is going to be pi over 3, or 60 degrees, and from there what we could do is substitute back into that. It works for this because it's a nice number, but in the case where it's not a nice number, what we can do is we can actually do 1 squared plus 2 squared, which is going to give us r squared cos squared alpha plus r squared sine squared alpha, and that's equal to 1/4 plus 3/4, which is equal to 1. Then you'll see that we can factorize out the r squared to give us cos squared alpha plus sine squared alpha, which is equal to r squared, which is just equal to 1 from down here. So that's going to give us r is plus or minus 1. And generally when we make this, we assume r is greater than or equal to, actually it's just going to be greater than 0. So r is positive when we do this. Generally, that's what we assume. I think the reason for doing that is because if we made r negative, then we could have just used a different compound angle formula, and we could have got a different value for alpha. So that's equivalent to if r was negative, that's equivalent to moving it backwards. And you also notice if r is negative, then these don't follow anymore. Reason we get two solutions is because we square it, so we have to eliminate the negative value. So therefore we get r is equal to 1. So what this all comes down to is we can rewrite this left side as simply 1 multiplied by sine x plus alpha, which is pi over 3. And that's just going to be equal to the right side, which is root 2 over 2. So that gives us x plus pi over 3 is either equal to if we take arcsine of root 2 over 2, we're going to get pi over 4, but we're also going to get, using pi minus the primary answer, we're going to get 3 over 4 pi. So those are actually our two answers. And generally you'll have some kind of range to work with regarding x. So you have your primary and second answer, you subtract it, and then you can just plus or minus 2 pi times n to get all the remaining answers. So yeah, that's basically how the harmonic form works to solve these kind of equations. And now I'm going to show you how we can bypass it. And what it involves is actually deriving a formula. So I'm going to put this formula here again. A sine theta plus b cos theta equals c. And what I'm going to use is a weighted stress substitution. So let's let t equal tan theta over 2. Then if you've watched my previous video, you know that sine of theta can be written as 2t over 1 plus t squared. And cos of theta can be written as 1 minus t squared over 1 plus t squared. Just like that. And now I'm trying to remember if it's actually that way around. Yeah, I think it is. Okay. And then what we can do is we can substitute these back in. So this is going to give us a multiplied by 2t over 1 plus t squared plus b multiplied by 1 minus t squared over 1 plus t squared is equal to c. Now just doing some rearranging, I'm going to multiply out or distribute the brackets and also multiply everything by 1 plus t squared. So we get c plus ct squared. Then bring everything to one side. So that goes over there. We're going to get t in brackets b plus c plus t 2a. Sorry, that should be a minus because we're moving this to this side. And we're going to get, I'm going to write it like plus minus b plus c, like so. Okay, and yep, now using the quadratic formula, we're going to get t is 2a plus or minus the square root of 4a squared minus 4b plus c minus b. See how this is minus b plus c? So we're going to get minus b plus c here. But now if I change that minus to a plus, then we can distribute that minus throughout. So that's going to become b minus c like that. And that's all over 2 times a, or 2b plus c. Now I'm going to do a few steps in one go. So divide the top and bottom of a fraction by 2 just to get rid of that 2. So we're going to get a plus or minus 4. And this 4, if we factor out the 4 and then bring it outside the square root, that's going to give us 2. So we can essentially just ignore this 4. And that's going to give us a squared plus, now this is a difference of 2 squared, so that's b squared minus c squared all over b plus c, because remember we divide by 2. And there we go. So that's t, and remember that was equal to tan theta over 2. Which all in all gives us a nice and easy formula to remember, rearranging of theta as just going to be 2 times the arctan of this expression all over b plus c. And this is actually a pretty easy expression to remember. I'd argue this is easier than a quadratic formula. So I'm going to use it in the example we had above, which was over here. So a half, 1/2 sine x plus root 3 over 2 cos x is equal to root 2 over 2. And notice, if we put these numbers into the formula, we get a really easy way of evaluating it. This is going to give us the arctan of 1/2 plus minus the square root of 1/2 squared, so 1/4 plus 3/4, or just 1, minus c squared, that's going to be 1/2, so 1 minus 1/2 is root 1/2 all over b plus c, so root 3 plus root 2. I don't think, well, that can be simplified as just root 2 plus root 3 over 2. And yeah, that's pretty much it. Obviously remember that since this is an arctan, we can also add a 2 pi n, we can just add a pi n to each of these and you'll still get the same answer. So yeah, this is all of the solutions, and this is really easy to type into a calculator. If you remember this formula, then this was literally just one step, going from that to that, compared to all of this work and I had to do when trying to put it in harmonic form and then find the solutions from there. And even in harmonic form, you can make mistakes going from this to finding the complete solutions in the right range. So yeah, that was basically how to use a harmonic form and then how to bypass it using a weighted stress substitution in this nice formula. It's a really good formula to remember. And yeah, thanks for watching. I'll see you guys in a future tutorial. Bye.